Okay, so I wanted to give you a couple of illustrations on how to find these z-values using these confidence intervals. Think of a confidence interval as a middle area of the curve, and typically the most common confidence intervals that are typically thrown at you into problems are either 90%, 95%, or 99%. So the way you want to look at it is if I were to draw my curve, okay, they're basically saying that the middle area is 0.90. I'll use the first one, we'll just use 0.90. And so what you typically then do is you cut the curve in two pieces, so you have to look at it in half. Half of 90 is 45, okay? So in your tables, what they're basically wanting you to find when you get to the formulas is the z-values that correspond to these two data points. And the way you're going to get it from your tables, because your tables only give you half the curve, is your tables give you from 0 to z. So if I were to go to my table to try to find an area that's 0.45, so I go up here to my table and looking for 0.45, and to me it appears that the best candidates are either going to be right here or right there. Notice you don't see an exact number that says 0.45. So technically, tables you're restricted, and in a computer you can get the exact number. So you could either use 1.64 or you could say 1.65, because these two areas are the closest numbers from the table to correspond to an area that's 0.45. They're just guesses, but it's pretty much good enough for our purposes. But that would be your estimate for your z-value if you have a confidence interval that's, let's say, 0.90. So what if we had 0.95? So again, I'll draw my curve. I'll go ahead and put, again, just like I did before, 0.95 is the middle area. If I cut it in two pieces, you got 0.475 on one side and 0.475 on the other side. So, zero's in the middle. So we got a z there and a z there. So I go to my curve table, z-table, I'm trying to find 0.475, and this one is exactly in there, it's right there, and that's going to correspond to a z-score that's right at 1.96. So that would be 1.96, and then that would be 1.96. So I know they show you a little bit in the book on how to do that, but I don't think they give you a step-by-step approach. So I hope this kind of helps you understand how they're coming up with that. And I'll show you one more. I'll show you the 99%. So let's say you had 99%, and obviously if you divide that in two, you get 0.495 and 0.495. Remember, zero's in the middle, and you're trying to find basically this z-value. So if I go in here and I'm trying to find 0.495, to me the best two candidates are right there. I see 0.4949 and 0.4951. You can really just toss a coin to choose either one. You'd either see 2.57 or you can say 2.58. I believe in the solution manuals they use 2.58. So in any case, that's how you use these confidence interval percentages to locate your z-scores. And remember, you'll need this for both remember there's three scenarios if you go back to the PowerPoints: sigma known and your proportions. Okay, use the z-score.